بسم الله الرحمن الرحيم رب زدني علما.
Now, the next thing we'll try to understand about the encapsulation process, similar to IPsec, GRE encapsulation is similar. So, whenever you are trying to communicate between the two LANs, which are typically your private network, how exactly the things happens here. So, if we go ahead and take the same example, what we have been using in our labs, if you try to see, we did the configuration, we can see there is an end-to-end communication process between LAN to LAN after the GRE configuration. But again, how exactly the packet travels or what encapsulation, how exactly it's done. So let's assume that we are trying to send a packet which is sourced. Now this is your actual packet, let's say. Let's say this is my source. And here the source address is 192.168.1.1. So that's my source address, and your destination address is 192.168.2.2, let's say. So this is my destination address. Now we are trying to send an IP packet. Now this is your complete IP packet, which includes other information. Generally, typically your IP packet, it has an original IP header. In our case, it will be 1.1 and 2.1. That will be the original source and the destination address from LAN to LAN. And it carries some other data information, including your TCP, UDP, other information. So you will see the same information will be there. And additionally, on the top of it, it's going to add a GRE header and a new IP header. So it's going to add a new IP header along with a GRE header. These are the additional encapsulation or the additional information will be added to the original data. So if we see, let's say this is your original packet, it will be original as it is. And when it reaches, it will be original as it is. But in between, when it goes from the LAN to LAN, it will be as it is. But when it is going through your tunnel interface, it is going to add some additional information. And that additional information, as per our example, it's like it's going to add your GRE information. Let's say this is a kind of GRE, and then it is going to add a new IP header as well. A new IP header. So we can say like this is like the GRE information. Along with that, it's going to add a new IP header. Now this new IP header will be the public IPs, because once, like let's try to see, when you are sending the packet from the source address and the destination address, your packet starts from the LAN, and whenever it sees the source and destination are on a different subnet, it's going to simply send the packet to the router. Now once it reaches the router, now the router is going to check the routing table. If you see here on the router 2, we can say show IP route. If you are looking for 192.168.2.subnet, now the router says if you want to go to 2.network, you have to go via 10.0.12.2, and that is via tunnel interface. If you just wanted to make it simple, you can use show IP route command, and in that it says that if you want to go to 2.network, we have to go via 10.0.0.2 via tunnel interface. So which means in this case, the packet destined should go via 10.0.12.2, which is your tunnel 1.2 interface. But now the question is, this tunnel 1.2 interface is not your physical interface. So which means automatically any traffic which is tunneled, which is going through a tunnel, is going to go based on this source address and this destination address, because that is your tunnel source and the tunnel destination what you have configured. So which means it's going to add the GRE header, and again it's going to add that the source address is going to be 15.0.0.1 and the destination address is going to be 25.0.0.2, which means when it is saying that okay, I should go over the tunnel interface, the GRE tunnel will be applied, and it's going to add a new IP header, and your packet will be routed out of this physical interface What is that physical interface? S1 by 0. Your actual interface which connects to the internet. And your packet will be routed based on this IP. So over the internet, not based on this. Because this is your original packet, it remains the same, but there will be additional IP information will be added, and then your packet is routed based on this address, and it goes to the service provider, and the service provider knows exactly where is 25002. It's going to send to 25002 over internet using BGP. That is again a complete transport network of the service provider. So again, we don't need to really worry on that, because once you take the internet connection, or once you use internet, it means that you will be able to reach the public IPs whatever you buy. So that's the job of the service provider. So we don't do anything on this part. So we just need to ensure before you build the tunnel, the reachability is there. And if the reachability is there, means you can reach. If there's no reachability, then you need to contact your service provider for that. So once you have reachability, automatically the packet reaches the router to the remote end of your tunnel, because it is a point-to-point. And once it reaches this router 2, now it's going to remove your headers. It's going to remove this, and it will be routed to your 2.0 network based on this destination IP, that is to remote LAN. So the same thing is again the same thing summarized here as well. If you see, the source address and the destination address remains the same as your original packet, where it starts, where it ends. But in between, when the tunnel interface comes up, this will be added as a source. This will be added as a destination. So this is going to be your source and the destination, and that will be the new IP header which will be added, and that will be used when the packet is being routed over the internet. So the same thing applicable if you're using IPsec or IPsec, the same thing applicable, just there will be instead of GRE, there will be an IPsec header, or if you're using DM VPN or Flex VPN. So most of the tunnel based VPNs, the similar thing happens. So the packets over the internet will be routed based on the public IPs, based on the new IP headers, not based on your actual, not based on the actual LAN IP addresses. So that's the reason this kind of transport mode, we call it as a tunnel mode. And this is the default mode in general, where there will be a new IP header added. So these packets, as I said, it will be using the public IP address to route your packets over the public network between the two private subnets.